In this video, we are going to cover the primitive section of the toolbox located on the left-hand side of the user interface. In fact, let me go ahead and collapse down the other sections of the toolbox, which I can do by clicking on the small black triangles you see above each section. Now, also, just to make things a little easier for you to see, I'm going to maximize my perspective viewport. Let's navigate back until we can see the red builder brush. Now, in my show flags, I have the grid currently turned off. I'm also going to make sure that toggle brush polys is turned on. So let's go ahead and select our red builder brush, and we can see exactly what the red builder brush looks like. Also, just as a side note, I have the show use the widget option switched off, so we don't have a widget in our way. Now, for starters, let's talk about how these buttons actually work. And you can see we have a cube, a cone, a curved staircase, a cylinder, a linear staircase, a sheet, a spiral staircase, a tetrahedron, and a volumetric thing, a volumetric shape. And really, in general, the only important brushes that we're ever going to use from our primitive section will be cubes. Sometimes you might need a cylinder, you might need to use a sheet, and every now and then a cone. Really, everything else being the curved staircase, the linear staircase, the spiral staircase, the tetrahedron, and the volumetric, you really will never have to use. But we'll go ahead and briefly cover them so you can get an idea of what they do. So for starters, if you left-click on each one of these buttons, you'll notice that the red builder brush changes into that shape. So I just clicked on the cone, and I now get a cone. It's kind of a flat cone, but as you can see, it is a cone. In fact, I'm going to hold down the L key and left mouse drag, and we can rotate around it so you can see what it looks like. If I click on cylinder, we get a cylindrical shape, kind of big. I mean, it's more of an octagon, but it is a basic cylinder. We can change the number of sides, and I'll show you how to do that a little bit later. We can bring up the curved staircase, which is kind of plain looking. Please, just to drive it home, I'll be saying this throughout this video over and over. Don't ever use this. We have the linear staircase. We have a sheet, and this is useful every now and then. I mean, I've used it in several occasions, especially like if you need a water surface, maybe to make put a material on so that you can have water look like it has some sort of a cool material on it. We have the spiral staircase, which currently doesn't look all that good, which doesn't really matter. You wouldn't want to use it that often anyhow. We have the tetrahedron, which is just going to look like a very basic diamond. I don't think you should ever, ever, ever use this brush, but here it is all the same. And we have volumetric. And what this will do is create, right now, just two sheets that are crossing through one another. Now, what was this used for back in the day, Logan?
Well, that was used to give the appearance of a volumetric effect before there were such things as particle systems. It was used to overlay a single flat texture over itself multiple times so that if you were to walk around this object, since the texture being mostly semi-transparent, you wouldn't be able to see the edges of the plane, but would instead get the idea that you hold the same amount of volumetric, volume as you walk around it.
Right, and they try to tell you that in the tooltip, used for torches, chains, etc. Actually, that's kind of a misnomer. I wouldn't use it for anything these days.
Right, it's more of a vestige. It was used in older times before we had more advanced systems like static meshes.
Exactly. Now, that's just creating each of these basic primitives just at a click. And, you may not always want a cube that is 256 units cubed. You might want maybe something a bit more rectangular, something bigger, something smaller. And you can access the properties of each one of these primitives by right-clicking on their respective button. So if I right-click on cube, we get the properties of this cube. So we can change its dimensions in X, and Y, and in Z. So let's make this a 1024, and I'll delete out the remaining numbers. I'll press the down arrow key, and we'll set Y also to 1024. Press the down arrow key again, and I'll set this to, say, 512 units. I can change my wall thickness if I like. So basically what this will do is set how big the walls will be, but only if the hollow option is selected. Because what this is going to do is carve out the inner part of the cube, and this will allow me to determine how thick the walls are. I can set this to a group name, and I can also tessellate it. Let's just go ahead and build it with hollow set. And we get the following, which is a big cube that is already hollowed out, and I will go ahead and add this to the level by going under Brush and choose Add, and I think we should actually have something here. Let me hold down the L key and see if I can place a light, And let's see, do I still remember the command to move this up into the air? It turns out I do. That's hold control and left and right mouse together. So now we have a room. Now this is an additive level, which is the only reason I'm able to see anything right now, and that's why I had to hollow out this. And we'll talk more about additive versus subtractive levels in the video over world geometry and additive subtractive levels. But that's a quick look just at changing the properties of a cube in general. Now if I right click on a cone, we can change the properties of a cone as well. Excuse me. We can change its Z height. We can change its cap size, outer radius, inner radius. And I'm not necessarily going to go through each and every one of these. You can feel more than free to go in and experiment with them and see what each one of them do. But in general, they're going to be pretty cut and dry. So let's go ahead and close that. And all of these have their own settings. Like for a cylinder, as an example, we have its Z height. We have an inner radius and an outer radius. Now, of course, that's going to be important if we have hollowed this out. If it's not hollowed, really all we're paying attention to is the outer radius. We can control the number of sides to give it more sides or fewer sides. In general, you want this to have as few sides as you can possibly stand to get away with. Just keep that in mind for later on. We have, of course, the dimensions of a sheet. Again, I'm not going to go over each and every one of these. Just to drive home before we walk out of here, though, please make sure that you don't actually use curved staircase, linear staircase, spiral staircase, the volumetric, or a tetrahedron in your level. They're not really called for anymore. But just for the fun of it, just to show you that you can make cool-looking things with them, I'm going to just take the spiral staircase. We'll open up its settings so you can see them. So we have inner radius, we have step width, step height, step thickness, number of steps per 360. Just for the fun of it, I'm going to set this to 64. And number of steps we'll set to something really just ridiculously high, like 256. And so let's go ahead and build that and take a look at what our red builder brush just did. So if I zoom out from it, we just created a helix. Now that looks really cool, but you wouldn't want to use this because it would be a nightmare to texture. Each and every single panel of this shape would have a separate BSP surface that we would need to adjust textures on. Not to mention this would wreak havoc on calculations, so you never, ever, ever want to use this.
Right, this is the kind of shape that would be much better accommodated by a static mesh, something that could be as high resolution as you need, but would be more intricately modeled in an external application. Again, these are more older tools used before static meshes were actually put into the Unreal Engine, as in those days it was kind of the only way to make this kind of shape. Now that we have static meshes, it's much more efficient to use a static mesh in place of these types of brushes. That's
right, and I'm really glad you brought that up, Logan, because I've been sitting here saying the whole time, don't use the staircase, don't use the tetrahedron or sphere, and don't use the volumetric. And you might be thinking to yourself, if you're following along with the video, well, that's great, but what should I use if I need a staircase, or if I need some sort of volumetric effect, or if I need a sphere? Well, for a sphere or a staircase, you would generally be using a static mesh. If you needed some sort of a volumetric effect, in most cases you will be using some form of particle effect. Now, for the tooltip, we see this would be used for things like torches or chains. A torch would definitely be a particle effect where you can simulate very realistic fire, and we'll talk more about that in a section over particles. For a chain, you could use a skeletal mesh, which would be a simple chain mesh that you would apply a skeleton to so that you could actually make it rattle around and appear to flex and bend, as opposed to just being a simple effect as it is here, because actually this effect would be more expensive to calculate.
Right, and not to mention completely static. If you would go on the fully skeleton route, like you had said, you could make a chain that would actually whip around in the wind.
Right.
Depending on whether or not it was animated.
Right.
But here, this was an older system where it would be a completely static bar-looking chain.
Right, and I don't want to misspeak. I mean, I guess if you really only had one of these, it wouldn't be, quote-unquote, more expensive to calculate, but it's really not the way you would go about it anymore.
It would be unnecessarily expensive because you'd be relying on the BSP system to handle that kind of geometry, when the static mesh and hardware brush system can do that much more efficiently.
That's right, and in general, you always want your BSP to be as absolutely simple as you can make it, and that's something we'll talk about a little bit more once we get into a separate video. So that is going to be everything that you really need to know about the primitives. Again, you can just click on them to set the red builder brush to a specific shape, and really that's what these buttons are all about, is just manipulating the red builder brush so that you can add or subtract geometry from your level.
Right, it is key to understand that that's not actually adding any one of those shapes. It's more of the operation is set the builder brush to take this shape. It doesn't cause any change to the actual level.
That's right. And then, of course, you can right-click on any one of these and change the individual dimensions of each primitive. And that that is going to wrap everything up over the primitive section of the toolbox.